Today we'll be taking a look at the squeeze theorem. The squeeze theorem is something that can help you evaluate some pretty tricky limits. So let's get started. Imagine we have a function f of x so that at every point it's greater than h of x but less than g of x. So our function f of x could look something like this. Let's also say we're defining a point A. What the squeeze theorem states is that if the limit of x approaching A of h of x is equal to the limit of x approaching A of g of x, and if this is equal to a value L, then the limit of x approaching A of f of x is also equal to L. And this part is basically common sense, because it makes sense that if a function is sandwiched between two other functions, then when those two other functions come really close together at the same value, the function in the middle should be that value. Now let's see how we can use this theorem to help us solve a more complex limit. So over here, we have the limit of x approaching 0 of x squared times the sine of 1 over x. So first, let's define what is our function in the middle. And let's start with the sine of 1 over x. So this is only part of our whole function, but let's start with that. So if you take a look at the graph of this function, you'll notice it's always between -1 and 1. It always oscillates between those values. Now let's multiply x squared to this expression, and we'll get negative x squared is less than x squared sine of 1 over x is less than x squared. And so now we have our whole expression, and let's see what we can do with that. So our question is asking us the limit of x approaching 0. Now let's see what we can do. What is the limit of x approaching 0 of negative x squared? Well, it's pretty simple. That's just 0. Now how about the limit of x approaching 0 of x squared? Once again, that's 0. So now we can see the squeeze theorem taking place. We're starting to meet the criteria. So now, because of this, we can also state that because x squared times the sine of 1 over x is in between these two functions, because of the squeeze theorem, we know that the limit of x approaching 0 of x squared times the sine of 1 over x is equal to 0. And that's how you can use a pretty simple theorem, and you can use it to help you solve a more complex limit. And that's a pretty basic lesson on the squeeze theorem. It's definitely a good subject to know, because in the AP test in the spring, you might get a few of these questions. Thank you for watching this video. If you have any questions or any calculus subjects you'd like me to discuss in the future, just leave a comment down below. Thank you for watching. I'll see you in the next video.